Shared neutral multi-wire branch circuits remain common in commercial buildings, including office spaces, primarily to reduce conductor count and simplify wiring. However, electronic loads such as computers and lighting ballasts can generate harmonics, leading to current imbalances in the shared neutral and potentially causing overloading and overheating. When multiple office spaces share a common neutral, the risk of overloading increases with the number of connected devices. To mitigate these risks, firstly, limit the branch circuit load to below 80% of its rated capacity. Secondly, avoid connecting high-powered equipment like space heaters or large motors to multi-wire circuits shared with sensitive electronics. Thirdly, use ground fault circuit interrupters, GFCIs, to detect imbalances and trip the circuit, preventing overloading. Fourthly, consider separate neutrals in areas with high electronic loads to minimize current imbalances. According to the National Electrical Code, NEC Section 310.15 B4 C, the neutral conductor sizing for multi-wire branch circuits is determined as follows. Firstly, for two-wire circuits, size the neutral at 100% of the largest hot conductor. Secondly, for three-wire circuits, size the neutral at 70% of the largest hot conductor. These calculations pertain to the neutral conductor's current carrying capacity, not its physical size. For ampacity derating calculations, the neutral conductor is not counted as a current carrying conductor. However, it is considered when calculating conduit or raceway fill. In summary, multi-wire branch circuits with shared neutrals are still prevalent in office spaces. To ensure safety and reliability, adhere to these guidelines: limit the circuit load, separate heavy loads, use GFCIs or dedicated neutrals, and perform careful sizing and derating calculations to prevent neutral overloading and overheating. It is also essential to understand the impact of nonlinear loads on multi-wire circuits. Nonlinear loads draw current in pulses rather than a smooth sine wave. These pulses create harmonic currents, which are multiples of the fundamental frequency, typically 60 Hz. Odd-number harmonics, such as the third, fifth, and seventh, are particularly problematic in three-phase systems. The third harmonic currents, for instance, are additive in the neutral conductor of a three-phase, four-wire system. This means that the neutral conductor can carry more current than any of the phase conductors. If the neutral conductor is not properly sized to handle these harmonic currents, it can overheat and potentially cause a fire. Traditional incandescent lighting is a linear load. Its current draw is proportional to the voltage applied. However, modern electronic devices such as computers, LED lighting, and variable frequency drives are nonlinear loads. These devices use switching power supplies that draw current in short, high-amplitude pulses. These pulses create harmonic currents that can overload the neutral conductor. To address the issue of harmonic currents, firstly, specify harmonic mitigating equipment such as harmonic filters or reactors to reduce the amount of harmonic current generated by nonlinear loads. Secondly, oversize the neutral conductor to handle the increased current load due to harmonics. The NEC provides guidance on sizing neutral conductors for nonlinear loads. Thirdly, use separate neutral conductors for each circuit to prevent harmonic currents from accumulating in a shared neutral. Fourthly, balance the load across the three phases of the system to minimize harmonic currents in the neutral. The NEC provides specific requirements for multi-wire branch circuits in Article 210. These requirements address issues such as the identification of the neutral conductor, the use of common trip circuit breakers, and the protection of the neutral conductor. It's important to consult the NEC for the latest requirements and to ensure that multi-wire branch circuits are installed safely and in accordance with code. The NEC also addresses the issue of voltage drop in branch circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. To minimize voltage drop, firstly, use conductors that are large enough to carry the load. Secondly, keep the length of the circuit as short as possible. Thirdly, avoid overloading the circuit. The NEC provides guidance on calculating voltage drop and provides recommendations for maximum voltage drop limits. When designing branch circuits for office spaces, it's important to consider the specific needs of the occupants. This includes the type of equipment that will be used, the amount of power that will be required, and the layout of the space. It's also important to consider the potential for future expansion and to design the electrical system to accommodate future needs. For example, it may be prudent to install extra conduit and wiring to allow for future circuits to be added easily. It's also important to coordinate the electrical design with other building systems, such as the HVAC and lighting systems. This will help to ensure that the building is energy efficient and that the electrical system is compatible with the other building systems. Energy efficiency is an important consideration when designing branch circuits for office spaces. There are many ways to improve the energy efficiency of branch circuits, such as using energy-efficient lighting, using occupancy sensors to turn off lights when they are not needed, and using power management software to reduce the power consumption of computers and other electronic devices. The NEC provides guidance on energy efficiency in Chapter 8. It's important to consult the NEC for the latest requirements and to ensure that branch circuits are designed and installed in a way that maximizes energy efficiency. Safety is always the most important consideration when designing and installing branch circuits. It's important to follow all applicable codes and standards and to use qualified electricians to perform the work. It's also important to inspect the work carefully to ensure that it is done correctly and that the electrical system is safe. The NEC provides comprehensive requirements for the safe installation of branch circuits. These requirements address issues such as grounding, overcurrent protection, and wiring methods. It's important to consult the NEC for the latest requirements and to ensure that branch circuits are installed safely and in accordance with code. Furthermore, consider the impact of electromagnetic interference (EMI) on sensitive electronic equipment. EMI can disrupt the operation of computers, monitors, and other electronic devices. To minimize EMI, firstly, use shielded cables. Secondly, ground the equipment properly. Thirdly, separate power and signal cables. The NEC provides guidance on minimizing EMI in Chapter 8. It's important to consult the NEC for the latest requirements and to ensure that branch circuits are designed and installed in a way that minimizes EMI. Surge protection is another important consideration for branch circuits in office spaces. Surges can damage electronic equipment and can also cause fires. To protect against surges, firstly, install surge protective devices, SPDs, at the service entrance. Secondly, install SPD at the panel boards. Thirdly, install SPD at the point of use. The NEC provides guidance on surge protection in Article 280. It's important to consult the NEC for the latest requirements and to ensure that branch circuits are protected against surges. When designing branch circuits for office spaces, it's also important to consider the accessibility of the electrical equipment. This includes the panel boards, the circuit breakers, and the wiring. The electrical equipment should be located in a place that is easily accessible for maintenance and repairs. The NEC provides requirements for the accessibility of electrical equipment in Article 110. It's important to consult the NEC for the latest requirements and to ensure that electrical equipment is located in a way that is accessible for maintenance and repairs. Finally, consider the aesthetics of the electrical installation. The electrical equipment should be installed in a way that is neat and professional looking. The wiring should be run in a way that is concealed and protected. The panel board should be labeled clearly and accurately. A well-designed electrical installation can enhance the appearance of an office space. The location of the office, Windsor, Colorado, may have specific local amendments or requirements that need to be considered in addition to the NEC 2017 requirements. Always check with the local authorities having jurisdiction (OJ) to ensure compliance with all applicable codes and regulations. In addition to the technical aspects, documentation is crucial. Maintain accurate records of circuit layouts, load calculations, and any modifications made to the electrical system. This documentation will be invaluable for future maintenance, troubleshooting, and any potential expansions or renovations. Training is also important. Ensure that personnel who will be working on or maintaining the electrical system are properly trained and qualified to do so. This will help to prevent accidents and ensure the safety and reliability of the electrical system. When designing branch circuits for office spaces, consider the use of arc fault circuit interrupters (GFCIs). GFCIs are designed to detect arc faults, which are a common cause of electrical fires. GFCIs can trip the circuit and prevent a fire from starting. The NEC requires GFCIs in many locations, including bedrooms and living areas. While not always required in commercial office spaces, their use can significantly enhance safety. Consider the long-term costs and benefits of different wiring methods. While some wiring methods may be less expensive initially, they may be more difficult or expensive to maintain or modify in the future. Choose wiring methods that are durable, reliable, and easy to work with. Regularly inspect the electrical system to identify and correct any potential problems. This includes checking for loose connections, damaged wiring, and overloaded circuits. Regular inspections can help to prevent electrical fires and other accidents. When working with electrical equipment, always follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and using insulated tools. Never work on live electrical equipment unless this is absolutely necessary, and always de-energize the circuit before working on it whenever possible. Grounding is a critical safety feature of any electrical system. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Ensure that all electrical equipment is properly grounded in accordance with the NEC. Overcurrent protection is another important safety feature of any electrical system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overheating and causing a fire. Ensure that all circuits are properly protected with overcurrent protection devices of the correct size and type. The NEC provides specific requirements for overcurrent protection in Article 240. When selecting circuit breakers, consider the interrupting rating of the breaker. The interrupting rating is the maximum amount of fault current that the breaker can safely interrupt. Ensure that the circuit breakers have an interrupting rating that is sufficient for the available fault current at the point of installation. Load calculations are essential for designing safe and reliable branch circuits. Load calculations involve determining the total amount of power that will be drawn by all of the equipment connected to the circuit. This information is used to size the wiring, the circuit breaker, and the other components of the circuit. The NEC provides guidance on load calculations in Article 220. The neutral conductor carries the unbalanced current in a three-phase system and can carry harmonic currents as previously discussed. In single-phase systems, the neutral carries the same current as the phase conductors. Properly sized neutral conductors are essential for safety and reliability. Consider the use of isolated ground circuits for sensitive electronic equipment. Isolated ground circuits provide a separate grounding path for sensitive equipment, which helps to reduce noise and interference. The NEC allows for the use of isolated ground circuits in certain applications. When installing wiring in conduit, be sure to follow the NEC requirements for conduit fill. Conduit fill is the percentage of the conduit's cross-sectional area that is occupied by the conductors. Exceeding the maximum allowable conduit fill can make it difficult to pull the wires and can also damage the insulation on the wires. Consider the use of cable trays for running large numbers of cables. Cable trays are a convenient and efficient way to support and manage cables. The NEC provides requirements for the installation of cable trays in Article 392. When installing wiring in suspended ceilings, be sure to follow the NEC requirements for supporting the wiring. The wiring must be supported independently of the ceiling grid. The NEC provides requirements for supporting wiring in Article 300.11. Consider the use of flexible metal conduit (FMC) or liquid-tight flexible metal conduit (LFMC) for connecting equipment that is subject to vibration or movement. FMC and LFMC can help to protect the wiring from damage. The NEC provides requirements for the installation of FMC and LFMC in Article 348 and 350 respectively. When installing wiring in wet locations, be sure to use wiring methods that are suitable for wet locations. This includes using waterproof connectors and fittings. The NEC provides requirements for wiring in wet locations in Article 300.6. Consider the use of tamper-resistant receptacles in areas where children are present. Tamper-resistant receptacles have shutters that prevent children from inserting objects into the slots. The NEC requires tamper-resistant receptacles in certain locations, such as dwelling units. When installing receptacles, be sure to follow the NEC requirements for receptacle spacing. The NEC requires that receptacles be spaced so that no point along the wall line is more than 6 feet from a receptacle. This helps to ensure that extension cords are not used excessively. Consider the use of USB charging receptacles in office spaces. USB charging receptacles provide a convenient way to charge mobile devices. The NEC allows for the installation of USB charging receptacles. When installing lighting fixtures, be sure to follow the NEC requirements for lighting fixture support. Lighting fixtures must be supported independently of the ceiling grid. The NEC provides requirements for lighting fixture support in Article 410. When selecting lighting fixtures, consider the energy efficiency of the fixtures. Energy-efficient lighting fixtures can save money on energy costs and can also reduce the environmental impact of the building. Consider the use of lighting controls, such as occupancy sensors and daylight sensors. Lighting controls can help to reduce energy consumption by turning off lights when they are not needed. The NEC provides requirements for lighting controls in Chapter 7. Consider the use of emergency lighting in office spaces. Emergency lighting provides illumination in the event of a power outage. The NEC requires emergency lighting in certain locations, such as exit stairways and corridors. When installing fire alarm systems, be sure to follow the NEC requirements for fire alarm systems. Fire alarm systems are designed to detect fires and to alert occupants of the building. The NEC provides requirements for fire alarm systems in Article 760. In summary, designing branch circuits for office spaces is a complex process that requires careful consideration of many factors. By following the guidelines outlined above, you can design safe, reliable, and energy-efficient branch circuits that meet the needs of the occupants. Always consult the NEC and local codes for specific requirements and consult with qualified electricians for installation and maintenance. Remember, the 2017 NEC and any local amendments is the standard to follow in Windsor, Colorado.